Welcome today to the panel discussion from trustedfirmware.org. I'm Don Harbin, the community manager for trustedfirmware.org, and I'm joined by several of the active board members representing the projects. Joining me are Hauke from NXP, Kevin from NXM Labs, Kang from FutureWay, Joachim from Lenaro, and of course, Matteo and Shebu, both from ARM, and they're the co-chairs of the Trusted Firmware board. So thanks all for joining us today.
Great, thank you.
Hi.
Thank you.
Nice to be here.
Before we get going, let me bring up I'm going to share my screen and bring up the Trusted Firmware website. It's a really good place to kind of get us all on the same baseline. Hopefully you can all see that. And what I'd like to do is just walk through it real quick. What you see is the entry point. These blue boxes down here represent the projects, and the last box represents a very sophisticated Openci we've developed to put the membership boards in and to do the builds for many of these projects. If you drill down into one of these, it brings up what we like to call a mini website, and it shares some important information for developers, like where the detailed documentation is, how to get involved in reviews, where the source code is. It is a community project, so you can subscribe to the mailing lists. This example is TFA, of course, and it also has pointers to join some of the open tech forums. So that's a really good resource to use. Another important area is you can go to the join page. This gives a brief overview of the current memberships and their levels, as well as some supporting information like a slide deck that provides a little more detailed overview at a high level, and the charter and membership agreements. So wanted to just share that really quickly. And then with that above put in place, I just wanted to start with perhaps the team, that they can share a little bit about the value. So what, maybe starting with Matteo and Shebu, what do you see as a primary benefit of being a participant and a member of trustedfirmware.org?
Yeah, thanks, Don. So I'll go first. So I think there are two aspects that comes to my mind in terms of value of the collaboration. The first one is around the complexity which all the security architectures are undertaking. So if you think about it, there are more and more components which are getting added to security architectures. Components that needs to be developed, integrated, validated, and tested. For example, if you consider the ARM architecture and its direction, it went from the basic trust zone enablement, and it introduced the Securial2 architectural extension, and very recently, ARM has disclosed the confidential compute architecture as well. So all these components create a complexity, and this complexity has to be handled. And if one single company handles it alone, it's costly, right? It's a huge burden. So we have to have reference implementations, and the project is precisely set up to provide a collaborative platform, a community, where these reference implementations are developed, implemented, and tested by a pool of security experts from all the contributing companies. And that's really the key, one of the key values of the project. The second one that I have in mind is around the scaling factor that it provides for deploying security fixes into the real products. So it's not a mystery that firmware vulnerabilities are increasing. You know, attackers are targeting the firmware layers more and more. So having a centralized place, the community, with the security experts that, you know, find the proper fix for the specific architecture, and then test it against the relevant platforms, and then validate the solution, that is a great important value that provides, at the end of the day, a security by scale factor. So you fix and you deploy you fix and test security fixes in one place, and then you deploy it into products all around the world, into billions of products. So these are really the two factors that comes to my mind But now I'm going to pass to Hocker that might add something more on top of that.
Thanks, Matteo. Very valuable points that you mentioned there. And another important factor is time to market. And we at Trusted Firmware drive for aligned common interfaces and frameworks, optimize its architecture, get it widely reviewed, and once released, get them applied and reused really widely around the world. This allows engineers not to lose time on enabling interfaces and frameworks, but to focus on their efforts to differentiate on the service and solution they really care of. And at the same time, the underlying hardware and related drivers can also be optimized towards such standardized APIs and common frameworks. And next to the important aspects we have already covered, there are other investments Trusted Firmware is making, like the Openci, and Shebu will now provide you some more insights on that effort. Over to you, Shebu.
Thanks, Hockey. All valuable points. So coming to Openci, it's one of the most important investment that the project has made recently to enhance the collaboration amongst the developer community. Openci basically provides a cloud-based CI infrastructure that brings together multiple components like the source code review systems, Gerrit, Jenkins, and the Linaro validation system to provide an end-to-end integration and test infrastructure. Openci basically acts as a gatekeeper for all the source codes inside trustedfirmware.org. So effectively, any code that gets submitted to one of its projects gets picked up by this Openci system. It gets built for various configurations for various platforms, and it's only when the required regression tests pass, these code changes gets merged to the relevant code bases. I see multiple benefits in taking such an open test system approach. Firstly, collaboration becomes much easier. So developers across the globe from different organizations can rely on a common set of tests and platforms while developing features or fixing bugs. Secondly, as members of this project, they can add their platforms of choice to this open test system and make sure the platforms always works with the latest and greatest trusted firmware code base. Lastly, but not the least, it greatly improves the code quality as well, because in addition to regression test, we have other checkpoints like static analysis, etc., built in. We are continuing the Openci journey. Today, we have got Trusted Firmware M, Trusted Firmware A, Hafnium using Openci for day-to-day testing. We have got members actively adding platforms as well. So it's going to be an interesting journey with Openci. Again, a great value add to the project.
Okay, that does sound great, Shebu. You mentioned hardware in the Openci, so it's possible for members to put hardware into the system and have it part of the validation process?
Of course, yeah, that's one of the main value add by being members of this project as well. So as Diamond and Platinum members, members are allowed to add the platforms of their choice to Openci and make sure that testing happens whenever the code changes and make sure it all works together.
Okay, great. Why don't I shift over a bit to, I'll pick on Kang. I know you're a very strong proponent of open source. Maybe you can describe some benefits of trustedfirmware.org from your perspective on the various projects that are part of it.
Thanks, Don. Like any other open source project, Trusted Firmware project have relatively mature process. As mentioned, they have the policies such as coding styles, contribution and the review guidelines, and software license model and CI. So each project in Trusted Firmware is contributed by individual company at the beginning, and it become a Trusted Firmware project after approval of the board. Once it becomes a Trusted Firmware project, it is an open project for everyone and in the world. Due to the different origins that one may notice, like some difference among each project, right? The Trusted Firmware A probably is the most complete one, and some other new ones are just starting. One key advantage that for Trusted Firmware is that the architecture is mainly developed by ARM, with the contribution of member companies and ARM partners, such that all Trusted Firmware project works under a common architect defined by various open specifications, such as the firmware framework specification.
Okay, so if I understand, there's many contributors to Trusted Firmware. ARM, though, is providing the glue through firmware architecture specs to assure that the collaboration done by the community results in, say, a robust, validated solution that can be leveraged by the whole community. Is it safe to assume that the model can also reduce the number of potential vulnerabilities?
Yes. As everybody knows, Trusted Firmware is a security project, right? So due to the secure features that we have to reduce attacking surface, we focused on isolating each component through physical and logical ways. So all the components can be contributed by different vendors, and they still can operate smoothly together under the same architect and the common interface. Since all the components are provided with source code, it makes easier for security review and certification. A silicon vendor, for example, can use the verified source code to test their hardware compatibility. A platform provider will have many default features functional immediately, such that they can focus on added or new features or enhanced features. It also gives the product team a consistent way to add or port their own secure applications using a common verified architect.
Okay, so the common architecture coupled with, say, available validated source provides product developers both a great starting point for industry required certs, as well as making it easier to extend that code with differentiating feature sets, possibly. Is that right?
Yes, that's absolutely correct. So it's a very good model, similar to the PC OEM ODM model. The Trusted Firmware is really good for management feature, which is contained with the ARM hardware, such as the most widely used the CPU power management functions. And we only need minimum modification to add in secure applications in ARM-based hardware. This will be good enough for most of edge and the mobile device. But in a multi-architect cloud environment, there still have some challenges for ARM, since ARM is still not the dominant architect in that space. So our work has not stopped here, and we are moving forward, right? Because, for example, is the ARM confidential computing project is now being supported in Trusted Firmware. And for more details, you can look at another sections in Linaro Connect, the overview of firmware architect for ARM CCA.
Yeah, thanks, Kankan. Yeah, very quickly, yeah, trustedfirmware.org again is going to be at the heart of the enablement of the ARM CCA architecture as well. Trusted Firmware is going to provide yet again that collaborative platform to develop the relevant Trusted Firmware components required for ARM CCA, such as the Trusted Firmware RMM component to manage the realms, the new modified TFA monitor that runs in the root world, and of course modifications in the Hafnium SPM to manage dynamic secure memory. So you will start to see quite a lot of ARM CCA enablement happening under the trustedfirmware.org umbrella in the coming months and years to come. So exciting times for all the developers out there.
Okay, that's awesome. Yeah, I'd like to transition a little bit, though, over to Kevin, who comes more from a provider perspective. Kevin, a lot's been shared about Trusted Firmware itself, but how does this provide benefits to solution providers that are building on top of Trusted Firmware's foundation. Perhaps you can talk a little bit about how standardization of trusted services is making it easier, for example, for middleware solution providers such as NXM to provide value-added solutions to the market.
Sure, thanks, Tom. Yeah, so let's take a look at the IoT marketplace as an example. So this whole market, of course, is being transformed using this tool set to a platform approach, which is aimed at minimizing the impact of all of the variations inherent to addressing the needs of such a diverse market. So as one example, the range of solutions that we're talking here at the high end consist of multi-core processors based on Cortex-A, perhaps with co-processors, graphics process units, GPUs, natural processing units for machine learning, all equipped with gigabytes of memory and most likely running a rich OS based off of Linux. So that's one end of the spectrum. The other end is the complete opposite, which is kind of more feature constrained, often battery operated microcontrollers based on Cortex-M, probably running with a very limited amount of memory, perhaps 1 to 2 megabytes of memory. So given this complete diversity of devices and operating systems, how do we deal with that? Especially when you multiply that by the dozens of chip makers, hundreds of chips, and of course, all of those operating systems and real-time operating systems. So it's indeed a recipe for fragmentation. So the way to deal with this is the latest set of services, trusted services, which sit on top of Trusted Firmware for Cortex-A and are actually integrated directly into Trusted Firmware for Cortex-M. And essentially, these provide a single set of APIs for accessing some of the basic security building block features, such as secure storage, crypto libraries, and device attestation. And what's even better is these trusted services are designed to be extensible. So third parties such as NXM, who are looking at developing value-added tools for security services, are able to extend these built-in capabilities to address the specific needs of certain markets, such as those pertaining to the IoT device marketplace.
Okay. Kevin, can you comment maybe a little more on whether you see this approach as a jumpstart to, say, security appliance activities?
Yes, certainly. So a companion process for those who are interested is, once you've basically adopted the building blocks from Trusted Firmware, you're able to pursue third-party security certification programs. These programs are targeted at chip makers, middleware solution providers, and end product manufacturers, all of which can obtain the designation of Platform Security Architecture Certified, or PSA certified for short. In addition, if you're a chip maker, this includes inspecting any source code modifications that you may have made from the open source projects, as well as focused penetration testing. So as middleware providers or product makers who elect to incorporate these PSA certified chips, we can in turn save time and cost in obtaining the higher level certifications at the overall product level. And because has been mentioned earlier, Openci is being adopted, starting with Trusted Firmware for Cortex-M and TFA and Hafnium, along with the plans to add MISRA for static code analysis. We're continuing to see an improvement in the quality of the emerging open source code coming from each of these projects over time. And so this is in turn is streamlining the effort required by all ecosystem participants to adopt subsequent releases of Trusted Firmware into their shipping products. And in these investments that the Trusted Firmware ecosystem is making in all of these projects will help reduce the barrier of maintaining continuous security certification of the end products over time, which of course remains a major challenge for the entire industry.
Okay. Yeah, that sounds like Trusted Firmware is providing a powerful reference platform to build on top of, Kevin. Earlier, Matteo briefly discussed security vulnerabilities. Just question to the panel here. How do you handle security incidents on the project?
Hi, let me try to take that one on. So before giving you the complete answer, let me just give a little bit brief background. I mean, early on when we started working with Trusted Firmware, we decided to see if we could come up with a security incident process that was meant to basically cover all the different projects that we have. So we basically discussed internally as members, and we also discussed with the communities to see what we could end up with. So we have some kind of same balance between having the embargo periods, giving sufficient time for vendors to be able to reply and update their code bases. But also we don't want to delay it, so people could basically use the vulnerabilities for attacking systems. So this entire process is fully described and can be found on the Trusted Firmware webpage, the same page that you just showed when we started this panel discussion. There is a security tab on top. What happens when people actually report an issue is that we have a single email. It's some kind of catch-all email, we can say, for security issues. And behind that, we have a small team of people who act as the first responders. So this team in turn will involve the other members from the other team, so to say, where we have the experts in the different areas. These people are typically maintainers and so of the projects. After that point, we basically have meetings and emails and so on going back and forth, where we discuss between maintainers, the one who reported the issue, and in some cases we involve engineers from other companies, since it could very well be that there are certain parts of the code base that is maintained by an external engineer from a member company, so on. So yeah, to summarize, I mean, we have established a security incident process working across all the different projects right now, and that makes it quite convenient for the people who are reporting to this. And this process reminds very much of what you find otherwise in, as a branch standard and so on. Yeah, that's how it works, basically.
Okay, great, thanks. Yeah, we are starting to wind down the session here. Perhaps one of you could share briefly how to get more involved in the development and use of Trusted Firmware before we close.
Yeah, sure, Don. So one of the main things that you could do if you want to interact with the community, first of all, join the mailing list. It's very simple. Subscribe to the mailing list. There is one for every project. You can participate to the technical discussions, or just, listen to the discussions that are ongoing and follow all the technical topics. Another way to contribute is through the code reviews or the code itself. The code is developed in the open and reviewed in the open through our Garage servers. So participating in code reviews is a great way. You're contributing with patches to the project is another great way for contribution. We have wiki pages, documentations available through the website that Don showed before. All the documentation is there and can be evaluated. We have public tech forums, which runs on a fortnightly basis for both the application processor firmware and the microcontroller firmware projects. So these are live sessions in which you can discuss with the maintainers and with the project leads, and different topics are brought up every other week. These are fully public. Everyone can join and discuss these topics with the community itself and the maintainers. So these are some ways for companies and contributors to participate in the life of the community. And Shebu, would you like to add more on CI and member benefits?
Yeah, so in addition to participating in the various community activities that Matteo just mentioned, it's also worth considering becoming a member of trustedfirmware.org. In that way, you can join this team. You can have an active role in driving the strategic direction of the project by becoming part of the board. You also get to participate in the technical steering committee, which oversees the technical direction of the projects. And you also enjoy benefits such as Openci, where as an organization, you get to add your platforms of interest to the test system so that these platforms seamlessly work with the various Trusted Firmware projects. So please do visit the website to see more about the membership options, benefits you can enjoy.
Okay, that's a great summary. It's clear there's a lot of resources available and the tooling is in place for both members and non-members to leverage and contribute to Trusted Firmware. If anybody has any questions regarding membership or how to more actively participate, please don't hesitate to reach out. There's an inquiries at trustedfirmware.org on the website. We'd love to hear from you. So thanks to the panel for participating. It's been great.
Thank you.
Great.
Thanks, John.
Thanks,
Thanks for
everyone.
listening.
Thanks for joining.
Bye-bye.
Thanks.
All right.
Thank you. Bye-bye.
Bye-bye.